Well, good evening. We will continue from where we left yesterday. September 2021. So we will continue the next problem. Find dy by dx. If x is equal to a into theta plus sin theta, y is equal to a into 1 minus cos theta. So though I have worked this problem yesterday, but still I am going to work this for the sake of those who joined today. First find out dx by d theta. A is a constant, theta is 1, sin theta is cos theta. dy by d theta. A is a constant. One differentiation is 0, cos theta is minus sin theta, minus cos theta is plus sin theta. So dy by dx is equal to a sin theta over a into 1 plus cos theta. You can leave the problem here itself and get the complete marks because they have not given prove that dy by dx is equal to tan theta by 2. It is not given. They simply say find dy by dx. You can leave it here. But I am going to take the next step also. In case in some other exam, maybe the next exam, the same problem is being given and they ask you to prove dy by dx equal to tan theta, it would help. Otherwise, for this particular year, 2021, if you leave it here according to their question paper setting, fine, we have won. For simplification, you are using half angle formula. 2 sin theta by 2 cos theta by 2 divided by, you need to remember these formulas. So when cos get cancels, you get tan theta. This step you are writing only if the problem needs prove that. Otherwise, that is not required. Same here, they have asked a little difficult problem, not very difficult, but most unusual problem, which has not been asked in earlier years. That's the only year they have asked. Later also they have not asked this problem. But anyway, let me work that problem. If cos y is equal to x into cos of a plus y, prove that dy by dx is equal to cos square a plus y by sin a. Now these are all special problems. Unless you know the method, you can't work it out. Directly, if you start differentiating, you will not get this solution. These are all peculiar problems. So you should know how to work it out. How do you know? I am teaching you. How do I know? My teacher taught me. The process goes like that. So these are all special problems. So first write the step x is equal to cos y or cos of a plus. This is a step. This is totally different from the regular problems. Here, we follow a different method. Differentiate with respect to y. Normal differentiation is with respect to x. Here we are differentiating with respect to y. So x differentiation is not 1. X differentiation is going to be dx by dy. See, when y was there, we used to write dy by dx because we were differentiating with respect to y. Sorry, x. Here, we are differentiating with respect to y. So, what about this? This quotient rule. Keep the denominator as it is, cos of x plus y. Differentiate numerator. It is minus sin y. That's all. Whenever sin x was there, we used to write cos x dy by dx, or if cos x is there, minus sin x, because the differentiation was with respect to x. This is a peculiar problem. Here we are differentiating with respect to y. So cos y differentiation is sin y. We are using quotient rule. Keep numerator as it is. So differentiate cos of x a plus y. It is minus sin of a plus y. And we have to differentiate a, that is 0, and y is 1. Divided by, I am using the quotient rule. Let me recall that rule. If y is equal to u by v, dy by dx is equal to v into du by dx minus u into dv by dx divided by v square. Here it is not du by dx, it is du by dy. This kind of things will be having with it. So, but rule is same. V is denominator, we keep as it is. Differentiate numerator, you get minus sin y. Then keep numerator as it is. Differentiate denominator, you get minus sin a plus y. It's a same rule problem. Differentiate a, that is 0, y is 1. Divided by v square. Let us simplify this. Dx by dy is equal to. I will write this first term. Sin of a plus y into cos y. Just changing the position. I'm just changing the position, nothing more. I'll write this as second term. Cos of a plus y into sin y divided by cos square a plus y. So numerator is something like sin a cos b minus cos a sin b. That is nothing but sin of a minus b. Where a is a plus y, b is y. So this is nothing but sin of a minus b divided by cos square a plus y. That is sin a over cos square a plus y. But what is the answer they expect? dy by dx. What is that we have got? We have got dx by dy. Take the reciprocal, you get the solution. As I said earlier, this is a special problem. We differentiate with respect to y. And I have asked this question only once so far. Last 10 years. Only 2021 September. After that, I have not asked this question. So possibilities are there. Very appear. In case if it is asked, you can certainly work it. We'll move on to April 2022. April 2022. Here also there are two problems. First problem is y is equal to cos inverse of 1 minus x square or 1 plus x square. This problem has been asked in July 2016. It has been asked. Then they have asked again in August 2020. For 2 marks. For 2 marks they have asked this question, but now they are asking the same question for 3 marks. So I will not waste time working that because we have worked that problem twice already. The second problem in August April 2022 is if x is equal to a into theta minus sin theta, y is equal to a into 1 plus cos theta, 1 plus cos theta. Find dy by dx. Here also they have not asked you to prove something. They only said dy by dx. July 2016 and July 2018, the same question is about. July 2016 and July 2018. And asked this question, I worked it out. So I will just move on to the next question of August 2022. August 2020. Differentiate x to the power of sin x cos x greater than 0 with respect to x. Again, there is no need of working this problem because this they have asked in July 2016, March 2018, and September 2020. So I'll just skip that problem. The next problem in the same year, if x is equal to, I am writing all the problems so that you have a record of all the problems, one thing. Second thing is, yesterday I suggested, after the class is over, you need to work all these problems once again without referring to the notes. If you have the paper with you, no problem. If you don't have the paper, you can at least copy the problems and then start working. For that reason, I am writing all the problems. X is equal to a into theta August 2022 cos theta plus theta sin theta. Cos theta plus theta sin theta. Y is equal to a into sin theta minus theta cos theta. Find dy by dx. Again, I can save time because this problem has been asked in March 2014 paper and I have already worked that problem, so I can skip this. But I am writing all this for your convenience so that when you start revising the papers, you need not have to search for the papers. The problems are there with you. Now we will move on to March 2023. March 2020. Find dy by dx if x is equal to a into theta minus sin theta. Y is equal to a into 1 plus cos theta. Prove that is not there. So no need of working because it was the first problem that I worked today. And earlier years also they have asked this. So we'll skip that. The surprising thing is June 2023 they have asked the same problem. August 2023 they have asked the same problem. See, March, June, August, the same problem they have repeated. Today, in fact, I worked that problem. And there is no need of prove that also, just differentiate and leave it. What can they even make out when they have asked same problem in the all the three examination? Their interest is to see that at least the students will find it easy to pass the examination. As I said earlier, some student might think that oh, they've asked this in March, they may not ask. So don't do any such calculations. Now we move on to March 2024. No gambling, work all the problems. If x is equal to a into cos t plus log tan t by 2, y is equal to a sin t, find dy by dx, July 2015, July 2017, they asked this problem, I worked it out, so I can skip this. The next problem, same here, what they have asked is differentiate log x to the power of cos x. Even this, they have asked in 2014, July 2014, July 2019. So you can add the two for 2 marks they have asked. These 2 years I have asked this question for 2 marks. Now they are asking the same question for 4 marks. So I can skip this. And that year, 2024, there was 3 questions. The next question is x is equal to a into 1 plus theta plus cos theta plus sin theta. Y is equal to a into cos theta plus theta sin theta, theta sin theta. Y is equal to a into sin theta minus theta cos theta. Find dy by dx. No need of working because March 2014, then August 2022, then now they have asked the same question, so I can skip this. Let's go to the model papers. This year, PUC board has sent 3 model papers. So one advantage is we will solve all the problems. Of course, I am solving only the problems that are pertaining to differentiation here. If we find time, we can solve the other problems. In fact, the problem that I wrote, the last one, that is x is equal to a into cos theta plus theta sin theta. The last one I wrote, it is model paper 1. It is not August 2024. It is model paper 1. Now, model paper 2, if y is equal to 3 e to the power of 2x, this is model paper 2. Model paper 2. 3 e to the power of 2x plus 2 e to the power of 3x. Prove that d square y by dx square minus 5 dy by dx plus 6y equal to 0. Normally they ask this type of questions for 5 marks, but here they have asked for 3 because it's very simple. Doesn't deserve 5 marks, but they have asked a number of times also. In fact, I worked this problem during revision, but let me work again. You have to find dy by dx. Here 3 is a constant, e power 2x is 2e power 2x. Therefore, it is going to be 6e power 2x. Repeat, 3 is a constant, ku we are using. I keep constant as it is. Differentiate e power 2x. Derivative of e power 2x is 2e power 2x. So 3 into 2 is 6. Same way here, 2 is a constant. E power 3x is 3e power 3x. So this is going to be again 6e power 3x. Now we have to differentiate for the second time. D square y by dx. Again 6 is a constant. E power 2x is 2e power 2x. Therefore it becomes 12e power 2x. And here 6 is a constant. E power 3x is 3e power 3x. This is 18 e power 3x. Here we got 6 here, we got 12 here, 18 there because 3 e power 3x. Now, we have to prove this. So we can keep this as it is. We will take minus 5 dy by dx. So dy by dx is here. We have to multiply by minus 5. Minus 5 into 6 is minus 30 e power 2. I'll write here. Minus 30 e power 2x. And minus 5 into 6 is again minus 30 e power 3x. I am keeping d square by dx square as it is. 5 dy by dx is there. Minus 5 is there. I'll multiply this by minus 5. I get minus 30 plus 6y. We have to multiply y by 6. It becomes 18 e power 2x plus 12 e power 3x. I've solved a number of problems of this type. So what do we do here? We add the denominator left hand side 5 dy by dx plus 6y is equal to all this. This will cancel against it. And these types of problems with little more difficulty. One problem every year will appear in part D, which carries 5 marks. In fact, today I am taking up those problems. So and 5 marks you should be very sure of. So once I complete that, 5 marks there, 4 marks, one question of 3 marks, 7 marks, 2 questions of 2 marks, 7 plus 4, 11 marks, and 1 question of 1 mark. 12 marks questions would be completed. Then we'll go for part E. Part E we are not very sure whether we get differentiation, but it is normally application of differentiation. Okay. So model 3 paper. Model 2 is over. Model 3 paper. My suggestion is work all the problems of model 1, 2, and 3. At least 60% of the questions will be picked up from them. Maybe some 20% from paper 1, another 20% from paper 2. 40% they will normally make it difficult because if everybody same questions are given and if everybody gets very good marks, the deciding rank becomes a problem. So they may give 60% from that. So if you solve all the 3 papers, you are sure of completing this year without any problem. If this is model 3 paper, if x cube plus x square y plus xy square plus y cube equals 81. Find dy by dx. The moment do you see 4 or 3 or 4 terms, you think it's a big problem, nothing like that. It's a very simple problem of implicit differentiation. The moment you see power on y or more than one y term, it's an implicit. How to differentiate? You have to go term by term. First, let us differentiate x cube. It is 3x square. When you are differentiating, concentrate on the term that you are differentiating. Don't worry about the next term. I was concentrating on x cube. I got 3x cube. My job is done. Now I will have to concentrate on second term. What is x square y? It's a product. When it's a product, excuse me rule. So ask x cubes for y. Differentiate x square, you get 2x. Ask x cubes for x square. Differentiate y, you get dy by dx. So I have to use product. I keep y fixed, differentiate x square. I keep x fixed and differentiate y. Now I look at the next problem, next term. That is also a product. Same procedure. Keep y square, differentiate x, you get 1. Keep x, differentiate y, you get 2y dy by dx plus y cube is 3y square dy by dx. 81 is a constant, differentiation of constant is 0. Let us simplify this. 3x square plus 2xy plus x square dy by dx plus y square plus 2xy dy by dx plus 3y square dy by dx equal to. For the students who are attending my class regularly, I have given the direct method of writing the answer. Dy by dx is equal to. Just write a minus sign, put a bracket, and here also bracket. Look at the first term, 3x square. If the term is not multiplied by dy by dx, repeat, the term is not multiplied by dy by dx, send it to numerator. This is also not multiplied, send it to numerator. X square is multiplied by dy by dx, send it to denominator. Here y square is not multiplied by dy by dx, it goes to numerator. 2xy is multiplied by dy by dx, it goes to denominator. This is a method of writing the answer directly. Now 3y square is multiplied by dy by dx. It is not that you are shifting 3 terms and equaling. That's not a procedure. Numerator denominator can have different number of terms also. But what is the method is we group the dy by dx term on one side and the other side push it down to the other side. Why we write a minus sign? Because when you push all these terms, they become negative. That's why I put minus sign. But I am teaching you how to write the answer without writing that step of grouping. Okay. So with that, we have completed 3 marks questions of the second PUC public examination. Now we will move on to 5 marks questions. Five marks questions. Five marks questions. March 2014. If y is equal to 3e to the power of 2x plus 2e to the power of 3x, prove that d square y by dx square minus 5 dy by dx plus 6 equal to 0. Just now I told you, this problem carries 5 marks. But this year in the model paper, they have given under 3 marks. Maybe the reason is, we have already worked this problem, we have seen the working. That much of working doesn't deserve 5 marks. And this was asked in 2014. So examiners might have felt that 5 marks is too much for this. That is why they might have shifted to 3 marks. Anyway, I'm not going to work this because just 5 minutes back I worked this. So we'll move on to July 2014. If y is equal to 3 cos log x plus 4 sin log x, prove that x square y2 plus xy1 plus y equal to 0. 3 cos log x, 4 sin log x. So let me work this problem. Because I have used y2 and y1, we shall use the same one. Instead of dy by dx, I am writing y1. This is the problem of chain rule. 3 is a constant, cos is minus sin. So minus sin log x, and log x is x. Plus 4 is a constant, sin is cos log x by x. In fact, I worked this problem at time of revision. I told you, if you continue like this, you need to use quotient rule, but you can avoid quotient rule by multiplying by x. So multiplying throughout by x, multiplying by x, we get xy1 is equal to minus 3 sin log x plus 4 cos log x. Now we have to differentiate for the second time. We have to find dy by d square by dx square. Retain the answer because I have to copy that later. So let us differentiate this. xy1 is a product. So keep x as it is. Differentiate y1. It is y2. Differentiation of y1 is y2. Keep y1 as it is. Differentiate x, you get 1. So 1 into y1. I am using product rule. This is again chain rule. Minus 3 is a constant. So minus 3. Sin is cos log x by x. How? Sin is cos, log x is 1 by x. Here cos is minus sin. So minus 4 sin log x, and log x is 1 by x. Now again multiplying throughout by x. Multiplying by x. What happens? This x will become x square. X square by 2. This will become xy1 is equal to, both have got minus sign. Let us take it outside. 3 cos log x plus 4 sin log x. That is equal to minus y. You bring that minus sign to this side. we're going to get the solution. The same question, this question has been asked in July 2019. In July 2014 itself they have asked. 2014, July 2019, the same question. And again, July 2017 also. 17, July 2019. Then again, August 2023. August 2023. So 1, 2, 3, 4 plus this. 5 years. Out of 10 years, 5 years. 10 years means 20 papers. Because every year 2 papers. So out of that, 5 times they have asked this question. Not a difficult one. Go through that. Now we will move on to March 2015. March 2015. If y is equal to a e to the power of mx plus b e to the power of nx. See, that problem was 3 e to the power of 2x and 2 e to the power of 3x was a little easy because you had numbers. Here I got alphabets. Procedure is same, but you have to be little careful while working. Show that d square y by dx square minus of m plus n into dy by dx plus mn y is equal to 0. For the sake of understanding, I will write the same problem which I worked earlier. That was 3 e to the power of 2x plus 2 e to the power of 3x. The answer they expected was d square y by dx square. I am writing out of memory because just now we have completed that, plus 6y equal to 0. If you observe carefully, both the problems are same. A is equal to 3, B is equal to 2. So in place of 3 they have written A, in place of 2 they have written. Therefore A to the power of 2x and B. But what is M? M is equal to 2, N is equal to 3. Now here M is 2 and N is 3, M plus N is 5. And here Mn 3 into 2, 6. So both are same problems you should realize. So if you follow the procedure we followed for this problem, you will get a solution easily. Only difference is instead of 2 and 3, they have used M and N. So I'll work it out. So identical problem, I just want to work it out because M and N are there. Let us first find dy by dx. A is a constant, so it is m a e to the power of mx because a is a constant. Similarly, b is a constant, m b not n b e to the power of mx. Now we differentiate the second time. D square by dx square. We will get one more m square e to the power of mx. Because this ma is a constant, and keeping that your difference e power mx, we get one more m. Similarly, we get one more n here. N square b to the power of nx. So we have got this term. Now we need minus of m plus n into dy by dx. So we have to multiply this by m also and n also. Let me first multiply by m. When I multiply this, I get minus m square e power nx. When I multiply this, I'll get mn. The term is not there, so I write it separately. Minus mn b e to the power of nx. Repeat. I am multiplying dy by dx by m. So m into m square I write here. And I multiply second term, I write it separately because the term is not here. Now I have to multiply by n. When I multiply by n, I get mn. That is also not there. I write somewhere here. Minus mn a e to the power of nx. And I have to multiply second term. I get minus n square. So you have to be careful when multiplying. I wrote this because I identical I have written it below that. They are different I have written it separate. Now I have got to multiply y by mn. So mn into y. So this is y. When I multiply mn into y, the first one I am going to get is mn a e to the power of mx. I write here. Similarly, my plus mn b e to the power of nx. I write here. So now you just add the left hand side and add the right hand side. D square y by dx square minus of m plus n into dy by dx plus mn y. This will cancel, this will cancel, this will cancel, and this will cancel. If you can realize that 3 e to the power of 2x and 2 e to the power of 3x and these two problems are the same, absolutely there is no difficulty. Okay, let's go further. July 2015. If y is equal to tan inverse x whole square. If y is equal to tan inverse x whole square, show that x square plus 1 whole square into y2 plus 2x into x square plus 1 into y1 is equal to 2. So we got this problem. In fact, I have covered this while doing revision, but let me work again. We have to first find y1. It is a chain rule. First we have to differentiate power. This is 2 tan inverse x. Then we should differentiate tan inverse x 1 over 1 plus x squared. So the first thing you should do is shift this to left hand side so that you can avoid the quotient rule. So cross multiplying 1 plus x squared into y1 is equal to 2 tan inverse x. This you should remember. If you don't do this and continue, you'll have a lot of difficulty in differentiation because you have got to use quotient rule. The moment you can cross multiply, you get a product rule. The product rule you can easily employ then quotient rule because quotient rule has more terms. So product rule, keep 1 plus x square as it is. Differentiate y1, you get y2. Keep y1 as it is. Differentiate 1, that is 0. X square is 2x. So I write this as 2x y1 is equal to 2 is a constant 1 plus x square. Now multiplying or squaring both sides, or you can multiplying by 1 plus x square. Multiplying by 1 plus x square. What do we get? 1 plus x square whole square y2 plus 2x into 1 plus x square into y1 because this 1 plus x will cancel. Now, there is a question in July 2015, but they have asked this again in March 2017. In March 2018, same question. 2018. In March 2020, then August 2022, so these 1, 2, 3, 4 plus this 5 years. So they are repeating the questions number of times. We saw the previous one also. 3 log sin x plus 4 cos log x. That question and this question. Almost all the questions have been repeated. So that has saved my time. We'll go on to March 2016. March 2016 paper. Y is equal to sin inverse x whole square. Prove that 1 minus x square into d square y by dx square minus x dy by dx this is same as the tan inverse x problem. The only thing is you have to differentiate sin inverse x. That you should remember, it is 1 over root of 1 minus x square. So let us differentiate for the first time. It's a chain rule problem. First differentiate power 2 sin inverse x. Then sin inverse x is root of 1 minus x square. Avoid quotient rule by cross multiplying. 1 minus x square into y1 is equal to 2 sin inverse x. Now, you have got to use quotient rule. So keep root of 1 minus x square as it is. Differentiation of y1 is y2 plus y1 into, differentiate root first. It is 1 over 2 root 1 minus x square. Please recall the method of differentiation I taught you. You have to first differentiate root. Then enter inside. 1 is difference and 1 is 0. X square is 2x. But there is a minus sign, write minus 2x. 2 over root of 1 minus x square. I repeat, it's a product. So I keep root of 1 minus x square as it is. Differentiate y1, I get y2. I keep y1 as it is. Differentiate this root, I get. First I differentiate root. Then I differentiate 1, that is 0. X square is 2x. There is minus sign, minus 2x. Now we can cancel this 2 and 2. Multiplying by root of 1 minus x. What do you get? This root will go 1 minus x square by 2. minus this root, this will cancel. So minus x by 1. This will also cancel again. So this is the problem. I think they have repeated this problem also in September 2021. They have repeated this problem, and only 1 year they have repeated. But tan inverse x has been repeated more than 5 times. Identical problems, only difference is you have to use the tan inverse with the difference derivative is 1 over 1 plus x square. Sin inverse x is 1 over 1. Apart from that, the procedure is same. So we will move on to March 2017. Now, July 2016, I am not working because it is 3 log cos x plus 4 log sin x problem. And 2017 March, no need of working because it is y is equal to tan inverse x whole square problem. And July 2017, no need of working because it is 3 log cos x plus 4 sin log x. Then March 2018, y is equal to tan inverse x whole square, no need of working. And July 2016, write the problem, a to the power of mx plus b to the power of nx. Already worked the problem, so that I can skip. And March 2019 also, they have asked y is equal to sin inverse x whole square. This is March 2019. Just now we have worked this. Almost all the problems have been repeated. I think I have to mention this. August 2022 and March. August 2022 and March 23, there was a problem. Y is equal to 3 e to the power of 2x plus 2 e to the power of 3x. That they have asked. And with that, we have completed 5 marks questions of second period examination. And the part D is over. The part E has got 10 marks question, 1 6 marks and 1 4 marks. And normally you get a question from application differentiation, which I have not covered. What my plan is, after completing difference is over, when the papers also are completed, I want to revise integration basics and work some problems in integration. Then I go for applications. Now I want to take up integration immediately because integration differentiations are related. If you are good in differentiation, you find integration easy. After that, I am going to take up application of differentiation and application of integration. So I will straight away move on to integration because we have got some time now. Now that half an hour we have. So let me introduce integration today. So that I can take up the problems of. So before I go for integration, let me summarize what we have done. We have got 1 mark, 2 marks, and 5 marks question, 3 marks and 5 marks questions of derivatives. Now I will go for integrations. Afterwards, I will come for integration and the difference applications. Let me just give you some basics about this. Inverse process of differentiation. Inverse process of differentiation. The process of finding the function from its derivative is called integration. The process of finding the function from its derivative is called integration. I'll go a little slow here. So that the concept of integration, differentiation, the relationship between them is understood properly, you will find that if you are good in one, automatically you are good in the other one. In simple terms, if you say differentiation is a forward journey, integration is a return journey. I repeat, if differentiation is a forward journey, integration return journey. So if you take any function, differentiate it. After differentiation, you subject that function to integration, you are going to get back the function. So if you do both operations together, first differentiation, then integration, you get back the function. After we are familiar with both integration, differentiation, reverse order also we can do it. Take a function, integrate it, then differentiate it. The function will not change. So when any function is subjected to both differentiation and integration simultaneously, the function will not change. I've just given an idea. I'll give this clarity about this by taking a few examples later. So what is the we have written? Integration. Integration, S is not required, integration. Inverse process of differentiation. The process of finding the function from its derivative is called integration. Example. We know that the derivative of sin x with respect to x is cos. All of us know, differentiate sin x with respect to x is cos x. How do we write that? We say y is equal to sin x, then we write dy by dx as cos x. I've just written that in the words. Sin x, derivative of sin x with respect to x is cos x. Therefore, Therefore, we say that the integral of cos x, integral of cos x with respect to x is sin x. This we write in symbols. This symbol used. Integral of cos x dx is sin x. So this is what you have to understand. I say that integral of cos x is sin x because I know that sin x on differentiation gives cos x. So if I know the table that I have given you while doing differentiation, if you are all thorough with those tables, then you can write a corresponding integral formulas. So while writing integral formulas, I will be recalling the differentiation formulas, then write integral formulas. And it is going to help you in two ways. First thing is, I'm helping you to recall the formulas. Second thing is, you are able to establish the relation between integration and differentiation. So let me write one or two examples here. This is example 1 is over. Example 2, second example. Example 2. I write dx over 1 plus x square. Here, how do we read this? Integral of cos x dx is sin x. So what is the integral of 1 over 1 plus x square dx? I can write the answer provided I know which function on differentiation gives me this. All of us know it is tan inverse x. Supposing I write dx over root of 1 minus x square, or some students they say, sir, it is minus cot inverse x also. Yeah, equally to, because tan inverse x 1 over 1 plus x square, cot inverse x is minus of 1 over 1 plus x square, and minus cot inverse x is going to be plus 1. So you can guess the answer for this. This is sin inverse x, or you can say minus cos inverse x. Supposing we have sin x over cos square x. I've taken some examples to give you how the chapter progresses. Looking at the problem, we cannot write the answer because whatever answer we write here, on differentiation I should get this. So getting sin x over cos square x, maybe we might have used the quotient rule because that comes to our picture. Because in denominator has got power means. So in such types of problems, what you should do is use trigonometry and simplify. Sin x over cos square x. You can write this as sin x by cos x into 1 over cos x. Sin x by cos x is tan x. And 1 over cos x is secant x. So I am using trigonometry. Cos square x is written as cos x and cos x. Sin x by cos x is tan x. 1 over cos x is secant x. Now you can write the answer as secant x. Provided you remember secant x and differentiation will give tan x. So why I have given this problem to you is to make it clear that trigonometry's formulas are very important here. Formulas are very important. That you have seen in differentiation also, and you are going to see in integration also. I have given you maximum number of formulas. Maybe if I do integration, I'll just add one or two more, depending upon the problem standard. But if you are not thorough with those formulas, you are going to find integration difficult or differentiation difficult. So trigonometry is very, very important. So what is the conclusion we can write here? The conclusion we can write is, for integration, we are depending on differentiation. So this we shall note. There are no methods for finding before this note. I just want to make some points little more clear. Then we'll come to notes. So let me explain in general. In general. Afterwards, I'll come to the notes because I want to give a general example. What's the general example? Integration of f of x dx is equal to capital F of x, where d by dx of capital F of x is equal to small f. This table will explain the integration. When you integrate f of x, you get capital F of x. Why? To differentiate capital F of x, you get small f of x. So if you are a good student of integration, some of the CET problems in integration can be worked out easily. To differentiate the answer given, you must get back the function. Not all, some of them. Here, we call small f of x as integrand. Capital F of x as integral. The process of getting integral from integrand is called integration. So you should be familiar with this term: integrand, integral, integration. Integrand is a function subjected to integration. Integral is a result. Integration is a process. I repeat, integration of the integrand is integral. In other words, integrand on integration gives integral. Integral on differentiation gives integrand. So integrand is a function to be integrated. Integration is a process. Integral is the answer. The integration of the integrand is integral. The differentiation of the integral is integrand. That is, if you take integrand and integrate, you get integral. The function I'm subjecting to integration, I'm calling it integrand. If I integrate that integrand, I get integral. You take that integral and differentiate it. You get the integrand. Integrand is a function to be integrated, integral is the result, integration is a process. If you take integral and differentiate, you get integrand. So integral and differentiation gives integrand. Integrand on integration gives integral. This concept should be very, very clear. So let me put it in words or in symbols. Integral of d by dx of f of x dx is f of x. That means I am differentiating a function. At the same time, I am integrating, I get back the function. Now, I am differentiating the function. At the same time, I am integrating it, I get back the function. Now we shall put that down. There are no methods for finding. See, in differentiation, we had got what is called first principle method. That is not there here. Finding the integrals. When I write the note here, now you can understand what is integral. That's the answer of the functions. To a very great extent, we depend on the results of differentiation. So we don't have a standard method here. If we recall differentiation, we found the derivative of sin x or cos whatever it is using the method called first principles method. But here we are developing integration chapter, borrowing the results from differentiation. So to a very great extent, because once we got the integrals of the smaller functions, then we can develop integration using that. Just as we did in differentiation, we had different rules. Afterwards, we had our complicated rules. We had addition rule, quotient rule, chain rule. Then we had in one problem itself all the rules. Like that, integration process develops. But basic thing, we have got to list it out. And if you are, as in case of differentiation, I was expecting you to remember the results of differentiation, that is the derivative of the function. Same way, if you can remember the integral of the function, the chapter is not going to be that difficult. So let me go a little further. Consider the following. I am taking a little more time for basics because I want strong basics. Once the basics are strong, the concept is clear, the chapter development is going to be very, very easy. As I said earlier, foundation should be very strong. Y is equal to sin x. Y is equal to sin x plus 37. Y is equal to sin x plus 243. Y is equal to sin x plus 4689. I'm taking just 4 examples. Now, if y is equal to sin x, what is dy by dx? It is cos x. And what about here? That is also cos x, because derivative of 37 is 0. This is also cos x, because derivative of 243 is 0. This is also cos x, because derivative of 4689 is 0. Now let me recall what is that we have said. To take a function, integrate it, you get an answer. If you take that function, differentiate it, you get back the function. Now what we do is, we have taken a function, we have differentiated, we got cos x. Now if I want to get back cos x, I must integrate this. So if I integrate this cos x, I get sin x. If I integrate this cos x, again I get sin x, but I won't get 37. If I integrate this, I'll get sin x, but I won't get 243. If I integrate this cos x, I'll get sin x plus not 4689. Supposing this, if I simply integrate cos x, I get sin x, but I do not know the given problem was sin x like this or sin x plus 37 or 243. So that means there is a problem to come back to the point where we started. What was our argument? Integration and differentiations are inverse operations. If you perform both of them, absolutely there is no change, you get back the function. But here we are noticing some difficulty. I'll get sin x. I don't know it was only sin x or sin x plus 37 or 243, etc. So there is a problem. Whenever there is a problem, what do we do in mathematics? We run away? No. Even in life also, problem is there, you sit and solve it. Some problems cannot be solved. Then just like trigonometry, we write a solution, this problem has no solution. Lot of philosophies related to mathematics. Here, we'll go for the root cause of the problem. What is the reason for the problem arising? The reason is, when we are differentiating, the constant disappears. If it is there, it disappears. If it is not there, we don't know. So we are losing a constant in the process of differentiation. Therefore, after integration, we are going to add a constant for every problem. That constant is called the constant of integration, denoted by C. So you can just make a note. In the above examples, from the above examples, we notice that there are innumerable functions. There are innumerable functions whose derivatives are same. then bracket, because differential coefficient of a constant is 0. Hence, we add a constant to the integral See, integral means answer. Integrand is a problem. We are adding a constant to the integral answer, but not a problem, called the constant of integration. Denoted by C. So there are innumerable functions whose derivatives are same. Therefore, we are going to add a constant. It is called constant of integration denoted by C. So you have to note this. So what is the general form of integration now? The general form is in general. We change a bit. Integral of f of x dx is not just capital Fx, it is capital Fx plus c, where d by dx of capital Fx plus c is equal to small f(x). So this is the final thing. Many students ask us, sir, why should we add a constant? Reason is that when you are differentiating, the constant disappears. Therefore, when we get an integral, we are not aware whether the constant was there, it was not there. Was there or not? And you can just add one more word down. Since the value of the constant is indefinite, we are adding a constant C, but we do not know what is the value of the constant. Indefinite. These integrals are called indefinite integrals. So we have two branches in integration. The first part is called indefinite. The second part is called definite. See, what happens in this case is there is a C. The presence of C makes these integrals indefinite. If we want to make it definite, we remove C. That indefinite constant, if we remove, how to remove we are going to teach later. But much of difference is not there. The process of integration in definite or indefinite is one and the same. The only thing is in definite integrals, we will remove the constant because they would have given us some interval. And just help you to recall, you are given something like this: 0 to pi by 2 sine square x. This is called definite integral. If you are given no interval, this is indefinite. Both are differentiation, sorry, integration process is same for both of them. But here, by making use of this, these are called limits. We call this as lower limit and upper limit. Making use of that limit, we are going to remove the constant and make it different. I'll just explain that also so that you have an idea at what is definite integral. See, if you have a to b fx dx, same thing we write fx plus c from a to b. Then we substitute this upper limit first. F of b plus c minus we substitute the lower limit. I'll go for details later. I'm just giving some example to show that in what way they are different. F of a plus c. I cannot put a value for c, I have to put a value only for x. This upper limit first minus lower limit. Simplify this. F of p plus c minus f of a plus minus c. Plus c and minus a cancels. You get this as f of b minus f of a. I've just written it, just to give an overall idea of how it works out. I'll go going into the details once we start the problems. So, the answer for this is where d by dx of small fx is capital X. This is definite integral. So, these two tables will explain you the integration process, in what way they are different. So, with this I am closing class today. Tomorrow is a total in listing the formulas. Though it's a repetition, I will be writing all the formulas of differentiation, the corresponding forms of integration. It may take one and a half hours, or I may complete early. But for me, the formulas are very, very important. My advice for the students who are attending, when I am writing the formulas, please note down those formulas in your book, so that when we start working the problems, we can refer to that. Thinking that this video is recorded, it will be there for many more years. Anytime you want, you can refer to that. Waste of time. And the second thing is, anyway you are watching the video, instead of simply seeing like a film, keep a book with you, write down the formulas. That will take you. This is my advice. Only advices can be given. Whether to follow it or not, that's up to you. I don't force anyone. This is my advice. Anyway, you are sitting in front of the screen. Don't simply watch like a film. So if you can write down all the formulas, I am taking pains to write it because I know that at least there will be at least one student who will copy. For me, the purpose is that. So it's a right advice for all of you for attending class tomorrow. Keep a paper and pen with you, and I will be writing the derivatives, right side integrals, so that you can connect them. That is why normally after completing differentiation, I will not go for application, because I want the students to have a clear understanding of integration differentiation. Many students have complained, I have seen in colleges, oh, differentiation was very easy, integration is difficult, right? Differentiation is a forward journey. If you are traveled as a pillion rider, that means you are not worked on your own. definitely we cannot compare. Return journey is difficult for those who have not traveled properly. If you have traveled on your own, return journey is faster in fact. That's my understanding. Anyway, tomorrow one class will be just writing formulas. In case if I am able to complete the formulas, we'll start with the basic integration. And I'm going to, just as what I did in differentiation, there also, I'm going to give brief revision of integration before we take up the questions. Thank you. Shall meet tomorrow.